So welcome all to week 4 of Learning Analytics Tools problem solving session. I will not go through this because by now I can see some regular names, so you all know all this information you already have. We will be doing the recap of what has happened in the lectures first, quickly in some 10-15 minutes, and then we will go to the assignment questions. But this week, the focus of the lectures was on descriptive analytics. Okay, I will not ask, but I would, before we begin, let's check if how many of you have watched the video so that I'll go in that detail or I'll just give overview otherwise. Have you watched videos and come or did not get time to watch? You can hand raise or unmute and talk because we have very few people, so you can unmute and say also that you have watched the videos or you have watched some videos and not all. And okay, I started in watching, so I watched some videos and not all. Okay, fine, no
Only
worries.
some, ma'am, not all of them. Very few.
Okay, no worries.
As and when I get time. Yeah.
Yeah. That's what the NPTEL courses are for, so as in when we get time, we can watch the videos. That's the advantage. Yes, Hardik, you have watched the videos, okay?
Ma'am, am I audible?
Yeah, you're audible, yeah.
Ma'am, actually, I had one doubt regarding previous week assignments. There was one question where two classifiers are given, and accuracy, precision, and recall are given. And then we are asked to find out which particular classifier is better. So, I guess during the video lectures, they have mentioned that sometimes accuracy is higher, but recall and precision are lower. So in that case, imbalanced data is there, and we may not able to find out, which classifier is more competent or better.
Yeah, and in
So, ma'am,
case of
there is one
imbalanced data,
confusion in this particular question. Like in this question, how could we say that the linear regression is better? Because there is no much difference, or there is no much significant, difference in recall precision for given two classifiers.
Okay, what was the value, if you can remember?
Ma'am, could you please give me a moment, then I can just
Sure.
open.
And other thing which we can follow is just like last week, we can take up this discussion towards the end of the session.
Yeah, sure,
if
ma'am,
you're okay
sure.
with
Then
that.
I'm keeping the details ready, and towards the end I will
At
share.
that time, if you have the question ready, and if you can, we can share the question and have look at the question together, we'll be able to discuss it in better manner.
Sure, ma'am. We will discuss at the end of your session.
Yeah, so by that time you will also get time to get the details as well.
Yes, ma'am.
Let me just see. It is still eraser. I don't know. ठीक है. So this week's content was very easy. As in we all have done this, or we have heard about it. So it's not a new content. Like last week we had confusion matrix and all other, kappa, Cohen's kappa, inter-rater agreement, and all the big words which were new for many of us. But this week the content is familiar. That's what we have been doing since our school days. From school we have been plotting the graphs and interpreting the visual representations. So the same thing is done in this week. So if you all remember that pyramid of or the pathway, the pipeline of learning analytics, there was different types of learning analytics. So first was descriptive analytics, then we were to diagnostic analytics, and then slowly we went to prescriptive analytics, and then predictive analytics. So first predictive analytics and then prescriptive analytics. So in that way, the first thing is descriptive analytics, and as the name suggests, it is how we describe or how we represent the data which we have, as the name suggests. So in this week, the video lectures were focusing on different visual representations of data. When we have data either in Excel sheet or in any format, how can we visually represent that data? That is the focus of this week. So I will be talking about different types of visual representation, like bar chart, pie chart. Then we will be looking at the histogram distribution. Then these are the box plots, and then scatter plot and line chart to trend graph, and where we will be using those data, where to use what. Like there are different visual representations convey different purposes, are used for different purposes. So we'll briefly look at different purposes of different types of visualizations, right? So we will start from the simple representation, bar graph. As the name suggests, the data is represented in the form of small bars or scaled bars. Not small. Small is the wrong word to describe. Scaled bars. Right? Scaled bars. Right? So there is same variable for in different context. Right, so variable here is sport, and context is like what are different types of sports represent, preferred by how many students on y-axis. So very simple representation. Then comes a pie chart. As the name suggests, it is derived from the dessert pie. So the complete 100% of the data, how that data is divided into, how that data is divided. So whole, from many to whole, from whole sample to many, that's the connection of pie chart. So again, so where do we use, like bar chart is also conveying similar things and pie chart is also conveying similar things. So can they be used interchangeably? In some context yes, but in some context no. So we have to see what type of data we have. Right, so in pie chart, when user is expected to pick only one choice. Like suppose there are 100 students and each one has to take just one elective subject and not two elective subjects, so there can't be more than one overlap. So different electives, how many students have taken which elective out of the class of 100, that we can represent in pie chart, where we know that these percentage are gonna add up back to 100%. The pie cannot be bigger in size, when you add it separately, but whereas that is not the case in case of bar chart. In bar chart, if there are more than two electives and we have 100 students, so there will be 200 total n, like with all the subjects, all these contextual variable, which will be our elective subject. So in that case, their addition will not be 100%, it will go beyond 100%. So in that case you can't use pie chart. So the context of that variable is important. So when we have to represent the whole data divided into smaller parts, then we'll go for the pie chart. But when we have to same variable in different context, there could be overlap, then we will be using bar chart or stacked bar chart, where one is stacked above the other, like that, something like that. Girls, boys, if we want to represent that, out of 15 students who prefer cricket, 10 are 5 are girls, so we are representing these 5 are girls and rest are boys, like that. So in that case we will be using stacked bar graph, right? Stacked bar chart. So now moving on to histogram. So histogram talks about distribution. So have you heard about normal distribution, right? Bell curve. So this distribution is what is given by the histogram. So what we do is, if we have the data, how we will divide the data into bins, number of bins. So suppose these are the marks, mid-semester marks out of 30. So 0 to 5, in that bracket, how many students are there? We will make a table, frequency table, we'll call it frequency table. 0 to 5, there are 2 students. 5 to 10, there are 2 students. 10 to 15 marks, there are 5 students. 15 to 20, 5 students. 20 to 25, 3. 25 to 30, 3 students. So now we have how many students are there in which bin or which bracket. Yeah, so we will plot that continuously. So here you can see there is a pattern like this. Yeah, so this distribution pattern is represented by histogram. Yeah, so when we want to, so histogram is very widely used for grading. It is the by default visualization in many of the LCMs, where in many of the LMSs, where you insert the grade, and when there are automated grading systems or something in place, so they will follow this bell curve mechanism. They will follow the where is the maximum number of students lying in the bracket, and then they will decide that this will be A plus, this will be A B, and this will be B plus, or so on, so that's how the automated relative grading works. Yeah, there the histogram or distribution plotting will be used. Moving on to box plot. So box plot is little I mean, not everyone would have heard about it. It is little difficult to understand at first place, so I will advise, please go back to the lectures also, which are focusing particularly on box plots. If that is not clear, there are many simple videos on YouTube which explain how the box plots are plotted, or what is the logic behind these words called, quantile and percentile, all these things, no? So what is the interquartile range, and all these things are explained very nicely. Okay, so if you're not understanding what after what I am telling, then please go back and watch short 2-3 minutes videos on YouTube. There are many animated videos which talk about these statistical representations, right? So it is also one of the ways to statistically represent the data. Yeah? So what it will plot is the one box plot. What different things are plotting is, they will again, it will be based on the frequency plotting, right? No, in how many bins, how many students are there. So we will have the similar table like this, frequency table. So once we have the frequency table, based on that frequency table, we will find the median. Median is the maximum, the number which is appearing maximum number of times. No, that will be median. So we will plot the median, and we will see how many students are there. Like we will divide it into 4 parts, like the number of students. It is not based on like this absolute frequency, but we will see this division, the bin division, will be based on the number of frequency. These will be equal. Like if there is a class of we have the 100 students, so we will divide the 100 students into 4 groups, 25 25 25 25 each, and we will see where this top 25 is lying, where the middle 25 and 25 50 are lying, and where are the bottom 25 students, where is their score lying. So this could be the score. So this is just a random example which I picked from internet. So this could be our score on this axis, and we will plot where is the maximum number of, like the median value, and what is this 50 and 50, what is the marks range for these 50 students, and that will be Q1 and Q3. Yeah, and this will be like minimum value and maximum value, and these would be outliers. Yeah, so these are all things which we can plot in a box plot, right? So I'm not expecting you to understand all these words now. Again, I'm repeating that please, if you're not understanding this now, go back to the YouTube. There are small 2-3 minutes videos or 5 minutes video which will explain very nicely how these things are calculated, right? So I have tried to get the image which will have all these information for easier understanding when you go back and refer to this PDF. So you should understand what that is. So that's why I've chosen this image for now, and this will help in answering a few questions as well. So while we will attempt the questions, these things will be little bit clearer at how to interpret the box plots, right? So if you're not getting everything now, wait till we solve the question. If then also there are some doubts, then please, those animated videos are very nice, like 3-4 minutes videos, and they'll explain very nicely. So I'll advise, please go back to that also. That will make your concepts clear about which goes where, how to get the frequency, what are the quartiles, and all those things. Yeah, so now moving on to the next visual representation, which is scatter plot. So this is the scatter plot, and this is line chart. So as the name suggests, we will scattering of the data points. So there are x-axis and y-axis, there are many variables, and when we want to see what is the relationship or what is the correlation between these two variables, we'll do the scatter plot. For this value of x, what is the corresponding value of y? Yeah, this is x and this is y. So when we have to find the correlation between two variables, we will go for this scatter plot. So scatter plot will give us many insights, like where are the clusters, or what is the trend, like positive correlation, negative correlation. All these things are visually understood when we follow the scatter plot. Yeah. Again, line chart, when we have to have the multiple or annual, like year 1 mein what was the sales or what was the marks ka trend, then second year mein or second semester mein what is the marks ka trend, third year mein what is the marks ka trend, that. So here there are, like, for same year we have these different instruments ka sales trend plotted in this line graph. So we have to carefully choose what type of representation we want to use for representing the data we have, based on what data we have and what we want to convey. Okay, wait, I think there are, I don't know why this was happening, but I put this on automatic joining, but still there were some few people who were not able to join. Sorry. Yeah. So so based on our purpose, like what we want to convey, based on that we will choose what kind of representation we want to follow or we want to use, right? So now concluding, where to use what graphs, so when we want to, so as you have seen, when we want to do comparison of different variables in similar context, at that time we will use the bar chart representation. When we want to follow the distribution or the frequency type, in which what is the range, in which range how many students are there, so that type of distribution when we want to follow, we have three. Line chart also works well with distribution, plotting the distribution. Histogram is strictly used only for plotting the distribution, while box plot also uses the frequency or distribution plotting method, whereas line chart has the varied number of uses. So now coming to correlation, scatter plot is very widely used for correlation, for depicting correlation, where there is positive correlation, where there is negative correlation, what type of trend both the variables with respect to each other, what type of trend they are following, that can be seen by using scatter plot. Or line or stacked column chart also, like the column chart will also give you a trend. So how that will give, so instead of plotting this, we can have it represented in the form of such graphs as well, right? So line graphs and bar charts can be plotted in, like, same value can be plotted two ways, like line chart or bar graph. So we have to aesthetically look which is less confusing, which gives us quick interpretability, like line chart, if whether it gives quick interpretability, or such multiple graphs will give quick interpretability. So we have to choose between these, like we have to choose our representation based on all these things, right? So moving on to assignment questions of last year's. So question 1 says, which of the following is true for histogram, right? We have seen why the histogram is used and where it is supposed to be used. So now can you tell me what should be the correct answer? Okay, there is a question in the chat box. Let's take the question first and then we can solve this question. So given data, using visualization techniques, can we say it is easy to interpret? So generally what happens, Balaji, is when we have data, instead of looking at Excel sheet or CSV format data or JSON format data, if we have some visual representation, it is easy to understand. It gives the overall view of whatever data we have. It is overview at a glance. Yeah. So instead of getting to all the details of every variable about all the students in your Excel sheet, instead of that, if you know that your stakeholder or your students will be only interested in seeing their attendance for this month, so you can quickly give them a line graph of trend of their attendance with respect to previous month, this month, and so on. So visual representation is always part of a dashboard. If you see any kind of dashboard, Google Analytics dashboard is the easiest example, then YouTube dashboard, again, they will have this kind of visual representation, because picture is preferred. Pictorial representation is preferred. They say a picture speaks 1,000 words. So instead of reading 1,000 words, you just give them one picture, so that it becomes easy to understand what type of trend. Even if you're not reading the graph in detail, you know that okay, it is increasing or it is decreasing, the value is increasing, value is decreasing, what is the type of distribution it is following, whether it is skewed distribution or normal distribution. So those things are easier when you have visual representation. So when we discuss dashboards are not direct representation of any type of data in raw format. They are always visual representations. So that's why we should understand descriptive analytics. That's why we should understand what type of graph to use, when to use, and what is the importance of the context in all this setup, what we want to convey to our readers or what we want to convey to our stakeholders. So that is also an important deciding parameter. Yeah. So now coming to question, so I am getting option C. I have got one answer as option A and C. Okay, so I'll just read out all the options. So they are asking what is true for histogram. So histogram plots categorical data and has gap between each bar. Okay, different bean sizes lead to same result. Okay, bean size should be equal and bean size can be unequal depending on research question. Okay, so option C is correct. Bean size should be equal, because what we are doing is we are plotting the frequency. Yeah, histogram does the distribution of frequency plotting. So we will divide our data into equal interval. Yeah, divide data into equal interval, and we will see how many of our data points are lying in those intervals, and those number of that data points that will be plotted, and that is known as plotting of distribution. Yeah, so we will have the equal size of bean. There will not be any gap, because if we have marks from 0 to 100 and we are making that 100 का bins में divide कर रहे हैं, so we will have either 0 to 20 का 1 bin, 21 to 42nd bin, 41 to 63rd bin, 61 to 84th bin, and 81 to 100 last bin. Yeah, so we have these 5 bins, and we will see how many students are between 0 to 20. So there could be 0 students also, right? And 21 to 50, randomly I'm putting some numbers. 41 to 60, let's say 25 students. Then there are again 8 students, and there are 2 students. So we will plot these numbers. So that will be our histogram. Like यहाँ पे 0 आएगा, then second bin it is 10, so it will be somewhere here, and then 25 somewhere here, then 8 somewhere here, and then 2 somewhere here. So this will be the distribution. So either this, or we can have a line also. So this will be histogram for this data. Okay, so our bin size doesn't depend on research question. For histogram, bin size is fixed. We have to fix our bin size before we start plotting our histograms. Yeah, and there is no gap between these bins while we plot. So correct answer is option C. Right, let's go on to question number 2. So
I have one doubt, madam.
Yes.
Can we use the histogram for numerical, nominal, or categorical type of data?
Yes, so this talks about distribution of data. So even if your data is non-numerical or categorical, you can count the frequency of those categories, how many times that particular category is appearing. So instead of bins here, so these bins on x-axis is continuous bin for numerical data. So this distribution will be far better for numerical data. For categorical data, your distribution will be for one category, how many number of, what is the frequency. For category 2, what is the frequency. For category 3, what is the frequency. So if there are 2 categories, you will not have such distribution. There will be just 2 bar graph. They may not be connected, right? So that will not be a correct. Yeah, yes.
Ma'am, then we can call them as bar charts.
bar
Why
charts,
are
right?
they,
And why
why should we
call
call
them?
them as
Yes,
histogram?
absolutely. Why to call them? So they will not be connected. Yeah, I was actually coming to that point. So these bins or these
But we
charts
can't
will
call
not be
it as
connected.
histogram, na? For categorical data or nominal data, we use bar
Bar
charts. We
charts and
use
not these
histogram for continuous data. So in that case, they are two different things: histogram and bar charts.
Right.
Can we say that histograms can be used for categorical or nominal data?
So I just gave you an example. If we use histogram for categorical or nominal data, what happens?
That becomes a bar chart, ma'am. Then
Is it histogram?
no.
No, right? It is bar chart. So can we plot histogram for categorical data? Will it make any sense? We can plot, of course we can plot, but will that representation make any sense? Will that representation be any different from simple bar chart or simple line
It will
chart?
be a bar chart. Yeah, that's true.
Right? Yeah. So that's
Yeah, I
what.
got it.
Yeah. Instead of just giving yes or no question, I wanted to, convince you that.
Okay, ma'am. Thank you. Yeah.
Yeah. So I hope that's clear. We'll move on to question 2. So that's how we do discussion and doubt solving here. We discuss. We don't just say yes or no or this is the fact, because that's how we do it here. Okay. Yeah. So question 2. This is okay. So first tell me, what type of graph is this? Yeah. Can you please tell me what type of graph is this? Is this bar chart? Is this histogram? Is this pie chart? What is it?
It is a non-linear, madam.
Yeah, but what
Scatter
type?
diagram.
Yeah, scatter plot.
Because there is a dead zone,
Uh-huh.
saturation, and other things. So it can be called as-
Right. So we will not be using the words like that, saturation and all. I will not be uttering those words for now. Okay, not to confuse, because those things are, taking our discussions into totally different directions, which is not really needed for the scope of this course. Okay, so we will keep it very simple. I'm sorry. Yeah. So this is the scatter plot example. So scatter plot gives the relation between two variables. So this is x variable, this is y variable, how they are proceeding. So it is asked, what is the relationship between these x and y? Are they linear? Are they non-linear? Are they highly positive, like r is equal to 1, or it is negative correlation? Yeah, so I'm getting non-linear or non-linear, option B, non-linear by many. Option C. Oh, that was for previous question. Okay, fine. So yes, you are right. This is non-linear relationship, because as you can see the curve of which the data is following. Yeah, but it could be linear also. It could be highly positive and negative correlation and all those things. So based on where the line is growing, or where the points are, maximum number of points where they are congregating, based on that we can come up with the correlation between these variables by just looking at the scatter plot. Yeah. So now you understand what kind of information scatter plot conveys and what kind of information histogram conveys, right? So that is the aim of even the assignment, to help us understand where to use what data and how to interpret these graphs, right? So even though that's very simple thing, but to understand which representation to put where, what is the need of those representations in the first place, that's why we have these lectures, and this week's focus is on that point. Okay. So coming to question 3, which of the following statements are correct for bar chart in case of bar chart? Yeah. So option A says bar charts are used to represent the correlation. Bar charts can be plotted vertically or horizontally. Bar graphs are usually used to represent continuous data, and bar graphs are usually used to represent categorical data. So what do you think would be? Okay, I am very nicely getting B and D.
B and D.
B and D, yeah. So there is no confusion with this question. So we can have them horizontally or vertically. We can use them to represent the categorical data. So now, why we can't use them to represent the continuous data? We can take up that option also. What happens when we try to represent the continuous data? What will happen? It will not make any sense. Again, you remember this discussion, histogram wala. So for numerical data, we plotted histogram that told us for this range what was the frequency, and that made more sense. So instead of plotting that continuous variable, we have to that will be more confusing. That will not give the information, any information. It will be just, some numbers, some continuous, say, too many graphs, right? If there are too many things, and it will not lead to any kind of interpretability. But for continuous variable, if we choose to plot them in the bins, plot the frequency, that gives us more information, or it is easy to interpret. Yeah. So that's why B and D are the correct answers. One more thing, we have to put them in the bins. Okay, yeah, we discussed that. And only used for numerical type of data. Bar graphs, not really. Not really only for numerical type of data. We can use that for categorical data also. Bar graph representation, number of category 1 variable, category 1, what is the n, then category 2, what is the n1 and n2, category 3, what is the n3, and this n1, n2, n3 can be put on this will be category 1, category 2 and category 3. So likewise also we can represent this non-numerical data, no? So yeah. Okay, so moving on to question 4, we have to do the match the following thing. This we have done already, this we have discussed, so this should be easy, no? So we just have to match. So can you tell me what is the bar chart? One will go to what, A, B or C, D? Which thing? C. Yeah, C, right? And histogram, what do we
Distribution D.
distribution, yes, absolutely correct, D. Pie chart, if you remember the analogy of pie,
Part to whole.
Part to whole.
absolutely correct. And scatter plot,
Correlation.
correlation, where we will be just scattering individual data points, like two with respect to their values with respect to A and B2 variables. So that gives us correlation. Yeah. So let us write it down. One, oh sorry, I wrote 2 instead of 1. Yeah, 1 C, then 2 is D, then 3 is B, and 4 is A. So which is this option? 1C, 2D, 3B, B, option B, right? Oh yes, you guys were already helping me out there, but I did not see the chat box. Yeah, so option B. So this week's assignments are very easy, it's fun. I mean, it's not confusing. We already know many things. They're very easy questions. So question 5, which of the following statements are true for box plots? Okay, so with respect to box plots, right? So you remember that this kind of median and Q3, then this thing was Q1, maxima, minima. You remember that was the box plot. Okay, so now we have to say which is true. So option A says it shows we'll go one by one. It shows does it show outlier? Because we have to say what is true.
Yes, it is also true only.
Right, it also includes the outliers as well. What is outside the usual range, that also it plots. You remember that example graph I had shown you?
The outliers are the corner parts, right? Left and right, the end. So it shows the layer. Okay.
Yes.
I mean, the left means that minimum and maximum.
Above, like one thing which
Yeah.
goes beyond minima, beyond maxima will be outliers.
So it shows the outliers.
It shows the outliers. Absolutely correct. Yeah, it can be drawn for numerical as well as categorical data. We need to think on it, right? So let's go to C first and then come back to B. C says it shows mean, max and median values for a given data set.
Yeah, true.
True?
Yes.
Yeah. And A says box plot is not good at showing outliers. Is it true?
Opposite, no, it's false.
Opposite is
of-
true, right? So now let's come back to option B. Option B says it can be drawn for numerical as well as categorical data. So we know that numerical data ke liye to box plot works very well because it shows the outliers, also minimum value, maximum value. So when we talk about minima, maxima, outlier, frequency, that means we are talking about numerical data. But what happens when we plot, when we try to plot about categories, right? Okay, there is one question. So can we, Srinanda, can we take after discussion of this option B, right? We will come back
Yeah,
to your
please.
queries.
Sure.
Hmm. So what will happen when we consider categorical data? You remember we tried to plot the histogram for categorical data. So histogram deals with frequency. Frequency is how many numbers of our data point within that range, that we will count how many, what is an n number in that particular range, that we will count. So similarly for categorical data, similarly for box plot also, we plot the frequency. Yeah, so median is the number which happens or which occurs maximum number of times in our given data set. Yeah, so that thing, that means here also we are talking about distribution or frequency, how many number of times that particular data point is occurring. So in categorical data, does this make any sense to talk about frequency? Because we know if there are two categories, we will have two different frequencies. We will not be getting any insights about quartiles or distribution and all those things, right? So this is not true. It can't be drawn for categorical data, but we just have to deal with the numerical data or the continuous distribution of n numbers, right? So that's why option B is not true. Only option A and C are true. Yeah, so now let's take up Srinanda's question. She's asking, can we please discuss on how to find the outliers beyond minima? Yeah, so minima value, so let's go back to the diagram example of box plot. Yeah, so let's have this thing in front of us. So so she's saying, is it Q1 minus 1.5 IQR is interquartile range, this Q1 minus Q3, this value, where the maximum number of, like I had said, if the 100 wala thing is divided into sorry, let me like this, 25 wala what is the value for all these students, that we will count, how many. So median is where the so if we consider this kind of distribution, so median is here. What is the highest value of distribution, where that is happening? Like this is the median value, this is x and this is n number of n, right? So this value of x is median. So now we will see ki median ka left hand side, so there could be, this could be here also, the maximum number of x value could be somewhere here and minimum could be somewhere here also. Here distribution, this could be like that as well. Yeah, wait, let me, oh god, it all went nice. Okay, you assume that this portion is not there. What is happening? Okay, you assume that this portion is not plotted. So now we know that this is the minimum value which is occurring in our data set. Okay, we are talking about our data set, and this is the maximum value. Say for example, this is the marks ka distribution. Here we are trying to represent marks which our students have gotten in end semester ka exam. Okay, so ye minimum marks hai, this is maximum marks, and this is the what you can say, the score which is obtained by maximum number of students. Yeah, so ye middle aa gaya. This cannot be 50, this could be 60 also, this could be 70 also. If the paper is easy, this could be 90 also. Like 90 number, वो उसमें बहुत सारे number, बहुत सारे students have scored 90 out of 100 और बहुत सारे students have scored 60 out of 100. So that is the median value. So it is not the middle of the data points. Like if 100 marks का paper है, so 50 median होगा, ऐसे काम नहीं करता. Median we calculate based on our frequency of distribution, right? So this is the frequency distribution. Now what we will do is, if there are 100 students in our class, we will see कि median के आगे what is the range of 25 students, where are they, what is the number of x or what is the number of marks which they have scored, and 25 students on this side. Yeah, so that's what we will do, 25 students ahead and 25 students behind, that we will find out. So this will be quartile 1 and quartile 3. Yeah, यहाँ से यहाँ तक Q1 ये Q2 है, and then Q2 से Q3 है, which is like 25% and 25%. And next 25% will be this range, which will be Q4, and here this will be least bottom 25%, that will be Q minimum, towards minimum, the first quartile. ये होगा first quartile, यहाँ से यहाँ तक ये होगा second quartile, ये होगा third quartile, and ये होगा fourth quartile. Like that we have distributed our 100 students into 4 quartiles. So now what happens is, this is all frequency based. Okay, so we have 100 students, we have 200 students, that time it works really well. But what happens when we are talking about all NPTEL scores where we have lakhs of students? At that time, this minima value, this can't be like कोई fail नहीं हो रहा है, so सब pass हो रहा है, so सबके marks are starting above 40. It may not happen. There could be someone who could have failed and who could have scored beyond that 30 वाला marks. So that one student that might be somewhere here, यहाँ पे उसका x यहाँ पे कहीं होगा, right? And that one student who might have gotten 100 out of 100, तो यहाँ पे मैक्सिमा इस फॉर्मूला के हिसाब से अपना जिस तरीके का डिस्ट्रीब्यूशन है, लाइक नॉर्मल डिस्ट्रीब्यूशन इफ वी आर फॉलोइंग, देन द वैल्यू ऑफ मैक्सिमा कुड बी say we can say that roughly it could be like somewhere around 90. But there is this one student who have scored 100 out of 100, वो यहाँ पे कहीं है, उसका x है यहाँ पे कहीं, who has scored the 100 out of 100. So इस टाइम पे in such scenarios, in such cases, this data point becomes the outlier in given data set. Or somebody has scored 10 out of 100, but rest all students, unka score is between 40 to 90, and there is this one student who has scored 100 out of 100 and one student who has scored just 10 marks. So in that case, these will be called as outliers. Yeah? So this minima and maxima, these values are given by these formulas which we are talking about. But there could be a singular data points, 1 or 2 data points which could be beyond this, because we are talking about frequencies, we are not talking about absolute numbers here. We are talking how many students are occurring in that particular range that we are talking, right? So that's why there could be, because this works based on the probability of these many students occurring in that. Okay, so that's why there is a possibility that it can go beyond this maxima. There could be 1 or 2 data points. So that's why, even though mathematically this is the most likelihood maximum value, but there could be data points which could go beyond this, will be positive outliers, and will be negative outliers which are below minimum value. Yeah, so minimum value, if it is less than minimum value, then it is minima outlier, and if it is more than maximum value, then it is maxima outlier. So why it is 1.5 and why not 2 and 1.75? It is 2 sigma, that rule, what it is called, 2D. So it's a statistical concept. It is based on the normal distribution principle, that the maximum values are in the range of 1.5 times to left side of this distribution of this bell curve, and 1.5 times here. So it is statistically proven. This number 1.5 is backed by lots of data. It has come up with a statistician. It's called, I think, 2 sigma rule. Yeah, to 1.5. So this also I will suggest for this question also. There are many videos on normal distribution, right? So that comes from the normal distribution. This number 1.5 comes from the normal distribution which our data follows. Yeah, so I'll suggest that's a different discussion altogether. So if you are more interested, Balaji, please go to YouTube and search for normal distribution and that standard deviation wala rule. Look for how the standard deviation works or standard deviation rule works. You will get SSD. So standard deviation is mathematically, statistically very common term. And when you understand how this standard deviation wala concept works, you will understand that the 1.5 number, or what the sample size 30, what is the importance of having n is equal to 30 in statistics. Yeah. So we have another question in chat box. For LXT dataset given to us, the minima threshold for outlier is roughly 6000. In that case, we have some outliers at the end too. Yes, I absolutely agree with you. You're right. Yeah, that could be the case. Okay, so when we have larger data set, we can, the possibility, the probability of occurring outliers increases, na? So out of thousands of data points, there could be one or two who could be scoring too less or too high, like out of. So when we call normal distribution, but while using Orange or Excel, I did not get any outlier at the end. Okay, but you can try using this formula to find maximum and minimum value. Okay, because what happens is when Orange or Excel they try to plot, they will consider the frequency, and they might see that there's only one thing occurring, so we will not plot that. We will not plot the outlier. That may happen. So I'll suggest apply the formula and see if there is any value in the data set which is beyond your maxima value or below your minima value. So minima was actually minimum value in the data set. That's good. And outliers at the other hand, other end being displayed. Okay. So there was not minimum like minimum outlier. There could be just the maxima side wala outlier in that data set. That's why this would be happening. So it's not a thumb rule that there will always be an outlier in the data set. There could not be outlier in the data set. Or there could be outlier only at the one end or the other end. Yeah. But the outliers at the other end being displayed, there was 5151, the first instance of the dataset. So I have not seen the dataset which is used for LXT, so I'll need more explanation about this. Sorry. Yeah, but you understood, right, this concept of minima and maxima. This you can, so LXTs are just for you to do it yourself and understand the concept in a better way. LXTs are generally not graded. They're just there so that you can discuss, you can have healthy discussions in discussion forum, and if there are any misconceptions by someone, your peers can address to it. So if you think that somebody has put in wrong answer or somebody's concept is wrong, then you can step up and try to reply to that thread, by correcting them or giving them the example to understand the concepts better. So that's the whole purpose of having LXTs in this course. Yeah, so yeah, we were on question 6. Okay, also in the order of LXTs, McKinley ranking wala questions was subjective. How will be? Again, I'm saying you LXTs are not scored. They are for they are to increase your understanding. Yeah, so you will have some spatial what you can say, that will help you in grasp the concept in a better way. So it is to make the content more learner centric. Yeah, so when we try to score everything, when we try to have assessment everywhere, then the course is
Hello,
not
can I
learner
hear me?
centric. Sorry,
Madam, we couldn't hear you, madam.
It's frozen. Acha, okay.
am I audible? With what is frozen? I have kept my this thing there. Yeah, I am here. My internet connection is also here. Hello, am I
We
audible?
cannot hear you.
Interesting. Am I audible now? Hello? Nothing. My video?
No, ma'am, you are not audible.
My video?
No, presentation is there, but your audio video are not there.
Okay. Oh my god, okay. Let's wait. What we can do? Let me try connecting audio video from my this thing. What you can see. Okay, wait. Let me. Hello, is it audible now? Yeah, echo because my laptop video is also on. So is it audible now? Oh shit. Wait. Now my output, like video output, is not working. Wait. Shit. Ruko. Wait. Settings. Sit. No. I have joined in companion mode from my iPad, so I'm not able to hear anything in iPad. Wait. Hello? Yeah, am I audible now? Okay, can someone speak something?
Hello, hello, hello.
Hmm. I can.
Can you hear us?
Yes, I can hear. Yes, I can hear now. It is showing that my audio and video are working. Hmm. I am talking. Can you hear now? No voice. Or am I audible? Because it is showing that I am. No video. Let me rejoin. Let me rejoin. Okay. Let us try this thing. Recall and rejoin. Okay. Okay. Am I audible now? Okay. Am I? Okay. Wait. Was it audible? Wait. Okay. Let me check the echo setup. Okay.
We cannot hear you, but video is okay.
Okay. Yeah, because now suddenly both the devices, the speaker is working, so now it is causing echo. That's why I'm not talking. Yeah. Now I'm still audible, right?
Yes.
Okay, great. Good. We can continue our discussion now. Okay, great. I don't know how this happened. It was showing that my connection was good and my audio and video was okay from this end, but still it was not getting across. Okay, doesn't matter. We solved the problem. Okay, fine. So let's come to question 6. Which of the following statement is correct? First, this is with respect to box plots. Okay, so we have to read the okay, wait. Okay, so we have to read the options in C. What exactly this is talking about. So when we read words like interquartile range, median and everything, so all these things, that means we are talking about box plots, right? So option A, so I'm getting a lot of answers, so all the answers are option C and D, but still I'm going to read option A and B as well, right? So option A says interquartile range is the difference between second quartile and first quartile. Okay, so let me again plot the sample. So this is median. Yeah, so you remember what was the median point? Median was the end point of second quartile, and this was from this to this, from this point to this point it was q1, from this to this it was q2, so this is q3 and this would be q4 ka range, right? So now what is the IQR? IQR or interquartile range. From this diagram, this is IQR, like this difference between q1 and q3. So is this second quartile and first quartile? No. So that means this is not the correct answer. So now let's read option B. Interquartile range is the difference between third quartile and second quartile. Difference just between third and second? No. So that's also wrong. Interquartile range is the difference between third quartile and first quartile, Q3 and Q1. Yes, so that is correct. And median is equal to second quartile value. That is correct, right? So C and D. Okay. So moving on to next question. Which of the following statements are correct? Okay, so multiple statements, because they have sent which of them are correct. Okay, so we will read all the options, and meanwhile you can start plotting in the chat box. What do you think is the correct? What options are correct? Okay, so A says scatter plot shows the relationship between two variable. Okay, or scatter plot is used to show the distribution of numeric value. Okay, then C says line chart shows variation of variable only with time. D says line chart shows variation of variable with any other parameter. Yeah, so what do you think is correct? I'm not finally I'm getting some answers. I was worried why nobody's typing in the chat box. Okay, so
A and C.
A and C, right? Okay, so why you think only A and C?
Scatter plot shows the relationship between two variables.
Yeah, that's
And
correct.
then C's line chart shows variation of variable only with time.
Only with time?
So-
Are you sure it shows only with time? Can we have some other variable on the
We
x-axis?
can have some other variable, but then even I had doubt while I was attending this question. Then I checked it somewhere. In the literature, it is given that line chart shows variation of a variable only with time. So that's the very reason I am speaking of C as the answer.
Okay,
I
okay. So you have read it
particularly
somewhere.
read this somewhere because even I was apprehensive that it could be D as well.
Right. Yeah.
So
So
I
you know
read
line.
it and
What is
then-
the other name for line chart? Do you know?
Regression lines are used to plot two variables x and y.
Have you
But then when
heard
one of them
trend
is C,
lines?
it is
Have you heard what trend lines?
Yes.
Trend lines. Okay. So trend is generally with respect to time, right? So you are absolutely right. It is with time only. It is with time only. So that's why I'm trying to link it with this thing like trend lines and other things I'm trying. So trend lines is another name for line chart. Right. But when we say only with time, it becomes very restrictive. But if you consider any bar chart, right, if of a continuous variable, not for the categorical. So if we plot some girls versus boys, like no girls and boys. So this is girls wala value, and this is boys wala value. Okay, this is number of students, and these are marks, right? So this is one way to represent using bar charts. So now, so this is not with respect to time, है ना? This is time has nothing to do with students and marks. Okay, so now we have stars, triangles as boys and stars for girls. What is this? A line graph with
Line
not
chart.
with respect to time, but with other parameter, other variable. Is it making sense? It is conveying
Yes.
number of students and marks, right? So trend lines, which is a special type of line chart, they are plotted with respect to time, but line charts we can plot with respect to any other variable as well, right? Are you convinced?
Madam, in a cricket match and all, they are showing the
Trend lines.
cricket scores of two teams with respect to overs and all in a line. That can count as a line chart.
Yes, that is a line chart. And again, very good example which we have seen day to day while watching a cricket match. So very good example, or very we can all relate to that example. So there is no time there, but still you can see such lines, such trend lines forming there.
Overs and all, first over, second over.
How many
Yes,
runs,
party.
right? Yeah. So out of option C and D, which you think is more correct?
Option A and D.
Okay.
On the second parod ending also.
Right? So everyone's convinced A and D. There is no confusion now, right?
Yes, madam.
Let's move on to next question. So
C and D are the answers, right?
no, A and D.
A and D.
Yeah.
Okay.
So scatter plot is not used for distribution. For distribution, can you tell me which type of graph we use to show the distribution? When we-
Histogram.
histogram and
And the
Bar chart.
Bar also. No.
and this type of graph, frequency distribution, how many students in which quartile is what we talk about when we talk about box plots, right? Yeah. So when we say distribution, box plot is also one of the representation which is used for showing the distribution of values across the range. Yeah. Okay, so moving on to next set of questions. So question 8, 9 and 10 have this one common this thing. Okay, wait, let me check. I'm not echoing right across thing because I'm confused. It is showing me muted
No,
here
madam,
and
you are not
unmuted
echoing.
there. So two devices and I jumbled up in between, no? So that there's confusion. So my presentation device is different and my voice and video device is different. Yeah, so I got confused. Okay, so now from this particular box plot we have to answer question 8, 9 and 10. So let's have a look at this box plot and we'll try to map it. So what should I name this particular corner point? Q1, Q2, Q3, Q4. What should be the name of this thing?
Q3.
No, look very carefully here on these numbers. Which should be Q1 and which point should be Q3?
Q1 is 30. Q1 is 30, right? Q1 is 30.
Yes.
Q2 is
Q2
80.
is 70 and Q3 is 80.
Great. Q3 is 80.
80 and Q2 is 70.
Q2 is
70.
around 70, I would say. This is
No, 75 or
around,
something.
yeah,
right?
around something.
Yeah,
Not 75, 71, 72 around. Yeah.
72. Okay.
Yeah, 72. And what is this value? Q2 is also known as median.
Median.
Yeah, median. And what is this value, this point? 90?
Upper quarter, what is it? Maximum.
Maximum. By mistake, I was writing
minimum.
minimum there.
Left
Yeah.
is minimum.
Left is minimum.
Extreme left, yeah.
Yeah, this is mean. Yeah. So now we have some numbers with us. Yeah, Q1 ka value we know it is 30. Q2 ka somewhere 71, 72 around. Q3 is 80. Maxima we know, minima we know. Okay, so now let us go to the questions and we'll try to, I think I have written the answers as well. No, thank God. Okay, so find the interquartile range or IQR. So what is the IQR? We have all the values. What is the formula for IQR? Which minus which is IQR?
Q3 minus Q50.
Yeah, so Q3 minus Q1. So what is Q3 minus Q1?
80 minus 30.
80 minus
So
30.
what should be the value of
50.
IQR?
50.
Yeah, so we answered one question. Let's move on to next question. Find the range of marks. Range of marks is
20 to 90.
yes, absolutely correct. 20 to 90. I'm so happy. Maximum value minus minimum value. Yeah, so what should be maximum minus minimum?
90 minus
90 is the
70.
maximum. 20 is the minimum.
I am very happy today. Yeah. Yeah. Okay. And what percentage of students obtained marks between 30 to 80? So 30 to 80.
50%.
Yes. Everyone's on fire today. So as I said, this is the 25% here and 25% here. This was the median. Yeah. So that means this particular range, or what we call it as IQR. IQR shows the distribution of middle 50%. And these are top 25, these are bottom 25. Yeah, I'll write here for better understanding. Top 25%, these are bottom 25%. Yeah. Okay, yeah, I can repeat the questions. This was the 50% mark. So this is the last question. So we have a lot of time at our hand. So let us. So these are simple formula, Shreya. Yeah. So we have this plot shared this box plot. So box plot representation notations we have to keep in mind before we try to even attempt to answer such questions. Yeah, so this value is always median value or Q2 value. And this square is called as also box or interquartile range or IQR. So IQR is difference between third quartile value and second quartile value. So as the name suggests, each quartile represents 25% of the frequency distribution. That means 25% of our data points are lying between these range 20 to 30. So if our class strength is 100, that means 25 students have marks between 20 to 30, and top 25 students will have marks between 80 to 90. This is top 25%, this is bottom 25%. So now 25% out, 25% out. How many remaining? Middle 50%. So this middle 50% are lying in this IQR range, interquartile range. That means half of our class, out of 100 students, 50 students have marks between 30 to 80. Yeah, so interquartile range is this question: how many students are lying between, oh sorry, my mistake, I have written Q2 here, it is not Q2, it is Q1. Yeah, so how many students are lying between Q3 and Q1 is the question here. What is the interquartile range? So interquartile range is Q3 minus Q1, which is 80 minus 30, 50. Yeah, so question 9 was find the total range of the marks. So what do we mean by range of the marks? On paper range of the marks is 0 to 100. Okay, but we will speak in terms of distribution. What is the minimum number of marks and what is the difference between maximum number of marks which students have achieved? So from where we will get that? From this point. This is the minima point, this is the maxima point, end of the graph. So we will see maxima is 90, minima is 20. So range is max minus minima, maxima minus minima, which is 90 minus 20, 70. That's why our answer is 70. Now last question, what is the percentage of students who have obtained marks between 30 to 80? How many students have obtained marks in 30 to 80? 50%, because this is the interquartile range or IQR, and 50% of our class or 50% of our data points lie between this range. Okay, Shreya,
Ma'am,
is
I
it
have
clear?
just one question. Sorry to
Yeah.
interrupt. I think this is done.
Done.
Question is
Yeah,
done.
please go ahead. Yeah.
Can I ask you? In this context, there was one question. I am not sure if this was already discussed, but because I was network was interrupting, and so I am not sure if I missed it out. There was one question.
Oh, I lost you. Am I still audible or this is still internet problem? Because suddenly
You are
her
audible,
voice.
madam.
Yeah, because suddenly she was talking and then I stopped hearing her voice. So I thought it's again internet issue or what? Okay, I'm audible.
Ma'am, one more doubt.
Yes, please go on.
If the mark scored between 70 to 80 means that 25% of the students have scored in that range. It's correct, ma'am?
Yes, absolutely correct. You are right. Yeah, this is distribution. So as the name quartile suggests, the quartile is quarter, 25%. So it is, we are distributing our data points as 25%, 25%, 25% and 25%, and we are plotting their range. In what range that 25% occur, that is the first quartile. In what range next 25% occur is second quartile. That's why it is not equal size, after median. If you look at this graph carefully, this distribution size is not equal. Yeah, 25% students lie between 70 to 80, but less, that this side of 25% students lie between 70 to 30. So it is not absolute number, it is frequency number.
Actually, I was asking you a question. Again,
we lost you in between. Yeah, please go ahead.
Yeah, the median was marked at 25, and the question was asked like this: I'm sorry. Give me a second.
So median is
Yeah, the
25.
question-
That means quartile Q2 value is at 25.
Yeah. And the approximate percentage of students having marks between 27.5 to 31 was the question.
I'm sorry, can you repeat the question?
There was a box plot given.
Ha, ha, ha.
The minima starts at 20, maxima at 30, beyond 35, it's somewhere between 35 and 40.
Okay, let's assume 35. Okay, yeah.
Yeah. And the second quartile starts at 25.
Okay,
Median is somewhere between 25 and 30.
So, if second quartile starts at 25, that means median is 25.
Okay.
Median and
No, but the
Q2
median
are
is
same.
marked somewhere between 25 and 30.
That will be this, like Q2, Q3 will be between 25 and 30.
Yes.
This
yes.
thing, yeah. So Q3 is different and Q2 is different, Q1 is different. Okay, so don't get confused. Yeah. So if they are
question
saying
is-
median is 25, that means Q2 is 25. Okay.
Yeah, Q2 is 25.
Huh.
The question is, consider the dark vertical line denoted by Y lying between 25 and 30 in the box plot. Then what is the approximate percentage of students having marks between 27.5 to 31?
Oh, okay. I need to see this question. I need to see this box plot if you can, because this numbers are very. I mean, yeah. If we have a graph, what I'll tell you with the example of this, like what I understand is your question values are somewhere between Q2 and Q3 and max value. You know. That's what my understanding is. So when we talk about quartile distribution, it is like 25%, 25%, 25%, 25%. So if it is between max and Q3 value, then it will be 25%. It is those 25% thing, yeah. I'm still not clear with the question because I don't have that graph in front of me.
I understand. The median is at, it is somewhere marked between 25 and 30. The Q2 is 25, as you say.
Okay.
But then the question begins at 27.5.
Okay.
27.5 to 31.
To 31.
That is beyond quartile 3.
Yeah, beyond.
I mean, 31, I guess
this value?
It lies in quartile
like
3.
This value which I'm highlighting, like, is this value from the graph which I just circled? From the graph which you have in front of you?
No. See, it is. See, the quartiles are marked from between 20 and 30.
Okay.
There's a line in between at 25 and 30 is the box, and there's a line in between.
Is it right? And there is somewhere line in between. Okay.
Yes.
Okay.
And the question says, what is the percentage? Well, it starts from 27.5 to 31.
Oh, okay. That's really ambiguous question. Okay. 30.
This is a part of the assessment, I should say.
This week's assignment?
Yes.
Okay. So I have got one question. Oh, so you can just copy paste the question here. Somebody can put the screenshot or share screen. I'm not sure if you're allowed to share screen. Okay. Yeah, it is clear, but this week, so we can't answer. Absolutely right, Balaji. This week's assignment, so I can't give you answer. Maybe next week we will come back to this question. I will keep this ready in one of the slides, but today we will not be able to discuss it because tomorrow is the submission for assignment. Okay, so if this is current assignment question, then I'm so sorry. We will discuss this next week. Okay, I'm going to.
In fact, I should say there were few questions which were answered today.
Okay.
From the same assignment.
Okay, but we will not do it purposefully. Okay, it's not ethical.
Okay. Yeah,
I didn't know this.
No,
Thanks,
that was the only question which was really, really confusing.
Really tough. Okay,
So
we will discuss this next week. Okay, next week's this thing we will have it.
Yeah, sure.
Okay. Okay, we have some discussions. Is this okay? So I will try to go back and get everyone's this thing. Okay. So I will start with Balaji's comment. Is there a difference between box plot and box and whisker plot? No. It is same name of, same name. Different name of same plot. So why it is called box and whisker is, this is box and these are called whiskers. the lines which are on both the side. Yeah, these are whiskers, so that's why it's called box and whisker also, and or box plot also. Yeah, so same name of different name of same graph. Okay, then again question is, if we got marks between 60 to 80, what is percentage? 60 to 80, that's difficult to answer, because we don't know how many students are between 60 to 70. We know that 70 to 80 there are 25%. But we don't know how many percent are total between 30 to 70. We know that there are 25%, but out of them how many have gotten exactly 60 to 70, that is not conveyed through this box plot. Yeah, so this question is really not answerable through the box plot. Okay, then we can't. Yeah, yes, Rakshit, you're right, we can't find between 60 to 80 using the box plot. We need more data about the distribution. You're right. Ambiguity is the dark line may not be median. That's really what you can say, that's rarely it can happen, because we have to, in box plot we have to show where there is no this thing anywhere where I have not marked. Okay, let's consider this. So it is very rarely it will happen that the box plot will have just this outer box and not the Q2 value plotted. Yeah, that's the whole purpose of having a box plot, so that we can have the quartile distribution, or the 25%, 25%, 25% distribution represented visually. Yeah, so it will rarely happen that this is not median. Yeah, because the box plot, the concept of box plot revolves around the median value. That's why I'm saying that it very rarely it will happen. Mani, are you sharing answers here? Please don't share answers here. Okay, it is clear in this week we can't answer. Yes, yes, Srinanda, you're right. That's the case for every this thing. Yeah, so I'm assuming that Naman has shared the question, which we will not be doing this week, but we'll be discussing that next week. Okay, yeah, next week just remind me, we will discuss this question. Yeah, next week we'll pakka discuss, but not this week. Yeah, okay. Any more doubts? We had somebody ask some question in the beginning, and we had said that we'll take that up at the end.
Yes, ma'am. Am I audible?
Hardik, yes, you are audible. Yeah.
So yes,
If you can share the question in the chat box, that would be great.
Yeah, actually, I'm trying to paste it because the question itself is of image, but I'm not having the right to, post an image. So,
but you can post the questions and we can.
Yeah, please give me a second. Give me a moment. I just copy it in text.
Sure.
It's a table, so let me write down in formal manner.
Okay, so Srinanda has this concern, LXT ka kya hoga, subjective questions. Okay, so Srinanda, I told you before also, LXTs are not evaluated, or they are evaluated but it will not be considered in your marking. The whole point of having LXT, so the full form of LXT is learning trajectory. So learning trajectory, as you know, this course follows the rule of learner centric MOOC. Yeah, so the goal of this course is to make the concept as much clear as possible to all the students who are taking this course. So how to ensure that? One way to ensure is that if there is any misconception happening, if there are any wrong points getting conveyed across to the learners, how to catch them is we ask them to put their understanding in the discussion forum, because that is one way to connect with you all. Yeah, so that's why LXT activities are given, that you go beyond just the lecture notes, lecture videos and PPTs and PDFs which are shared with you. You go beyond that and you explore the concepts more in detail, either by reading more concepts or by learning by doing it yourself. Yeah, so the purpose of LXTs is either you will be asking to do something beyond the scope of the subject, which will not be given in the PPTs or videos or all these things, and you explore or you extend your learning boundaries. Yeah, so don't worry about LXTs, don't worry about what is happening in LXTs, but please attempt the LXTs? Please answer in the chat box.
So
Please
will
answer in the
we
discussion
have such
forums.
subjective questions in the exam?
No.
Like comment on something?
No.
Okay.
No, don't worry about it. Yeah? So
Oh.
the exam questions will be of similar nature as that of our assignments.
Acha.
I'm sorry, I was listening to this LXT and I never came across any LXTs. Can somebody clarify this for me?
So in Swayam platform, where all the videos, on left hand side there is that tab where you get the week wise content, the videos and everything.
Huh.
So if you go back to that, you will notice that they have written LXTs.
Yes.
So we're
in
talking
chapter
about
4,
that.
if I'm not wrong.
Yeah, we are talking about that. So you will
Okay.
have that, those are whenever and wherever required, we have put the LXTs. Yeah, so LXTs are supposed to enhance your learning. They are supposed to help you achieve the learning objective, the broader goal of the subject. Yeah?
Okay.
So don't ignore it, but don't stress too much on LXTs. Yeah, try
Sure.
to do the LXTs, but don't let that make you more stressed. Okay.
Sure. Thanks a lot. I'm sorry I happened to
It's okay. That's why the
repeat the same
sessions
thing.
are. No, that's why the sessions are. Don't worry. We are here to discuss and answer the questions. So Hardik has posted the question in the chat box. So accuracy.
Yes,
I
ma'am.
will, Naman, I will come back to the histogram question again. Don't worry, we'll do that. But let me first take up this. Okay.
So, ma'am, two classifiers are given, LR and CP, and accuracy, TPR and TNR values are given. And the question is which one of these two is from the above data, we can conclude that classifier 1 is better or classifier 2 is better. Both will get the same results or data insufficient. So, ma'am, according to the solution, the correct answer is classifier 1 is better. So, I mean,
which is LR,
like,
right?
Yeah, LR. So, ma'am, is it exclusively based on TNR?
Do you remember what we discussed last week? F score, you remember that?
Yes, sir. Yes, ma'am. It's like more towards precision and recall, considering both of them.
Right. So, have you tried calculating F score using these values for these algorithms?
No, ma'am, I haven't.
Yeah. Try doing that. You will get your answer.
Okay, I got your point. So, like that way, we should think, not just looking at these values.
Looking at the data. Try to recall the formulae. What was this thing? So you remember last week we discussed what happens when we discussed what is accuracy, what is recall value, what is precision value. That we discussed. Okay, so accuracy was the straightforward accuracy. So accuracy can be manipulated by playing with the test data set and training data set. If you have more training data set, your accuracy will be more. If you use your 100% data for training and then you use your same data set for testing, then your accuracy will be 100%. Right? So accuracy is not always a reliable parameter. That's why we use recall and precision. So if you there was a difference between recall and precision. They all were dealing with how many predictions are correct and not how many predictions are wrong. So what happens when the data is not balanced, the data set is not balanced, then at that time we discussed about F score and other this thing like alpha value and all those things. So that thing, you recall the formula for F score and use TPR and TNR to calculate that, and you will get your answer.
Sure, ma'am. Thank you, ma'am.
Okay, so let's come back to Naman's query. Naman, which question histogram wala, the initial one, first one, or this bar chart, two variable, like this one, question 1, histogram wala you want? Or which question was it? This one? Okay, yeah. So here, how do we plot the histograms? We plot the frequency of data. Okay, so let's take this example of histogram plotting. Yeah, let's take this example of histogram plotting. I'm going to erase all these things so that we have blank scale for us. Yeah. So here is marks of mid-semester exam. For example, we have this table that 2 students, so frequency is how many number of students. 2 students have gotten marks between 0 to 5. 2 students have gotten marks between 5 to 10. 5 students are between 10 to 15. 5 are between 15 to 20. 3 are between 20 to 25 and 3 are between 25 to 30. So now here when we talk about histogram, we want to keep this bin size constant. Here bin size is 5. After every 5 we have grouped the total number of marks. We have made chunks. So here how many chunks? 1, 2, 3, 4, 5 and 6. So we have 6 bins for 0 to 30 range of marks. So this is what is happening here. So we will calculate how many students are there in these particular range, and we have plotted this here. So you will see this will give us a continuous graph. There is no gap in between. It's a continuous distribution of number of students for this range between 0 to 5, 5 to 10 and so on. So this is what it means. For histogram we will keep this bin size constant. If we have fixed bin interval 5, if we have fixed total number of bins, then the bin interval is also fixed, and our x-axis is of equal size. These values, these width of these bars is of equal size for a histogram. And we can also pass a smooth line, and it will give us some kind of distribution curve. This is also similar to histogram. So this is how histograms are made. I'm gonna read what is the long this thing is there in the chat box. So in chat box, Srinanda is saying histogram is generally used for quantitative data, whereas bar charts are good for qualitative data. This is little dichotomous. Okay, so we will take up, Srinanda will take up your thing after we finish that. Okay, so Naman, are there any more doubts in this? We'll go back to the question and now try to read and see if there is any confusion regarding any other option.
No, ma'am.
Yeah, it's clear now. Okay, so now we will go to Srinanda's question or point of discussion. Okay, can we consider qualitative as categorical? Then this can be true, else not. Okay, fine. So Srinanda, I want you to unmute and tell me what do you mean by qualitative? What is your understanding of qualitative? Or you can, if you're not comfortable, you can type in chat box also.
Yeah, it can be anything. It can be alphanumeric, it can be a student name, student's name, it can be subject name, it also can be category names.
Category names, okay.
College names, it can be address.
But what is qualitative? And what is quantitative?
Quantitative should be numeric.
Measurable quantity, right?
Measurable quantity, okay.
In easy to understand words, what we can measure is quantitative, right? Say for our marks are quantitative, our age is quantitative, right? So that is quantitative. Now what is qualitative data?
Something we can't measure.
Example?
All these things like college names, student names, address.
Okay.
Passwords, whatever.
Okay. So let's not go into passwords, okay? Keep the passwords away.
Okay.
We'll not discuss that. Okay. You are somewhat right. Which is
Subject
not
names,
measurable.
Names.
Subject names could be quantitative. Okay, let's not
Maybe
go there.
levels, like levels of study, like postgraduate diploma, blah blah blah. Diploma,
That is categorical data.
Category. So that is also qualitative.
No, that is not qualitative. In fact, even
Is it measurable numbers, quantitative quantity or something like that?
Yes. So everything measurable which we can measure very easily, like our marks, age, was quantitative. Or in categorical data also we can record, right? There are 3 categories, you have to choose between 3. There are number of 5 scales, you agree, you disagree, you strongly agree, you strongly disagree, you are neutral. You have 5 scales, and you are given statements and you have to say, okay, you agree or don't agree. So even that is measurable data, right? So that becomes quantitative data. Now what is qualitative data? What we are talking, the discussion which is happening, can we measure it in any way?
Not really.
No.
At least we can we can measure the frequency,
quantitative, no?
but we can't measure anything else. But for example, if we have address or maybe college name, or maybe student's name, they will not be categories. They will rather be qualitative, where we can't measure frequencies or anything else for that matter.
Yeah, college name we will not go into, because even college name could give us some information about the student.
So
it could be categorical data, right? It could be different categories, college A, B, C, 3 categories.
Right.
Okay,
It
so
can
let's
be
not go there. Yeah, but student's name also, we don't care about student name. Let's consider
Address.
student ID.
Yeah.
Address also we don't care. Address can also be categorical. If you want to group the students staying in the urban area or belonging to a particular state or belonging to a particular city, then we are categorizing them.
Okay, then
so that's
comments
also wrong
or
example.
queries.
What happens in discussion forum?
Yes.
There is something happening in discussion forum, but how do we measure that? So as somebody was saying categories, I think you only were saying categories, we will label something. Right? So in that case, what you will do is, we will do the discourse analysis. What we are talking, we are negotiating. We are agreeing on to something, we are disagreeing on to something. So we will have these labels there. And then we will use these labels, we will convert this qualitative data into a measurable quantity. We will try to understand after labeling how many times that particular label is occurring. So if we are now, we were negotiating about meaning of qualitative data, right?
So we are ideally introducing a new attribute. We are kind of imputing here.
Kind of, you're right. Yeah. Yes. So that is how we do the qualitative analysis.
Okay.
Yeah. So when we say, so again, when you're labeling something, that means you're categorizing something. So in your qualitative data, when you're analyzing your qualitative data, you are in a way handling a categorical data. That's why histograms are not a good option. Right.
So histograms generally used for quantitative. This part of the
continuous data. Yeah, continuous data, numerical data, continuous, which have continuous distribution. That type of data, histogram works really well. For other type of data,
quantitative may not be continuous. It may be discrete.
Yeah, because generally, when we want to convert qualitative data into quantity for analyzing, for representing, we use the labels or categories.
Absolutely.
Yeah, so that's why it is not the best way to represent frequency of qualitative data. That will be like bar chart only, na? We discussed, you remember the first question, I don't remember who was that lady, but she just very quickly she said, no, we can't do that. Then what's the difference between histogram and bar chart when we plot the histogram for categorical data? You remember our initial discussion?
Yeah.
She very nicely put up her thoughts that, okay, ye to same as bar chart, no? So what she had said at that time is exactly what this sentence is telling you, that histogram is generally used for quantitative data, whereas bar charts are good for qualitative data. I hope there is no confusion now.
So this is true or not true?
This is true. This is true.
Because again, quantitative can be discrete and continuous, and then converting
again continuous data. Again, continuous data, histogram.
Okay. Thank you.
Yeah. It's simple. I mean, it's all statistics, okay? So, and statistics is difficult to comprehend at first, but once you understand, you can't go wrong. Yeah. Any more doubts? Any more points to discuss? Question 2. Question 1, question 2. Okay. Yeah, Shreya, what's in question 2? So this is the scatter plot. Scatter plot is used to find the correlation or relation between two variables x and y. So here in this particular graph, there are these black marks are different points, and there is a trend line which we have tried to plot. This gray, can you see this gray line passing through? So this gray line represents the relationship between these two variables x and y. So is this gray line linear? No, it is positive, but is the intercept, the slope of the intercept 1 for this curvature line? No. So this is not high positive. Is this negative? For increasing value of x, is the y value decreasing? When for one variable, the other value, when one variable value increases, the other value decreases, at that time there is negative correlation. Yeah, so this is not negative correlation, because even for value of x, the respective value of y is also increasing, right? When x is increasing, y is also going up. Yeah, so there is no negative correlation. Is this linear? No, there is a curvature, right? It is curvature. So that's why it is non-linear. Okay, I'm gonna read some question. What is positive in scatter plot? Okay, positives in scatter plot. Naman, we will come to your questions later on. Okay, so future classes, if this is in scope, in future classes, please help us in Bayes theorem with simple example how to attack any problems. It is part of Bayes theorem will come eventually, and we will discuss this. Okay, yeah, while preparing for the slides, I'll keep Bayes theorem in mind. Okay, so now coming to positive scatter plot. So this is x and this is y. Okay, so this, we will consider this highly positive case. So r is the intercept, or sorry, not intercept, slope, sorry, my bad, not intercept, slope, or the degree of correlation. Yeah, so highly positive is how closely x value and y value are related. So this is r is equal to 1 ka line. So for every x, what is the value of y? For increasing, in what scale the value of y is increasing? So they are in similar scale, na? Whatever the value of x, whatever the value of y. So this is high positive, or r is equal to 1. So this is special case, r is equal to 1. But in general, positive scatter plot could be this also. For x value increasing, y value increasing. Or it could be this also. For x value is increasing, y value is also increasing, but the range of x and y is different. Yeah, so this is also positive correlation. This red dots are also positive correlation. And if we try to plot the trend lines here, then this is linear. A simple line is passing. Okay, now let us consider, let us consider this only. Yeah, let me use blue color. This is also positive correlation, right? X ka value increasing, y is also increasing, but this trend or the equidistant line is not straight line, it is a curve. That's why it is non-linear. It is not a straight line. That's why it is non-linear. Okay, so now I'm gonna read the chat box comments. Okay, if the value will linear and negative, then how will be the graph? I think your question is answered now, because we have seen the different examples, Shreya. For positive it will be linear. For positive also it can be linear, it cannot be linear. Like this is positive correlation, this particular graph, but the representation is not linear, right? So there are three different things which are not mutually exclusive, right? If it is positive, then it has to be linear. It is not like that. If it is positive, it could be curvature. The relationship can be a curve also. So it is not mutually exclusive thing. Okay, Rakshit is saying linear and negative looks like graph of x plus y is equal to constant. Kind of, yes. So from this equation only this r is equal to 1 comes, kind of. You want my YouTube channel link. Okay, it is shared with you. I will again share. I had kept it handy. Yeah, here it is. Okay, any more questions, any more queries? Okay, Naman, I'm not understanding your questions. I'm sorry. Need to make when using what? Which need to make when using visualization technique? It's not. Can you please elaborate more, either by unmuting or typing in chat box? Need the question, the concern is not clear to me. Srinanda, I'm gonna wait for a few seconds for Naman to elaborate on his questions. If he doesn't unmute, then you can unmute and talk. Because this question is really not clear and I'm confused what exactly you want to ask. Like, need to make when using a visualization technique. It's not very clear to me. You want to ask which visualization technique to use when, then this is the broad guideline. If you want to show the comparison, then you can use bar chart or stacked bar chart. If you want to show the distribution, then you can use histogram, line chart, or box plots. If you want to show the correlation, then scatter plot is the best.
There is a question for that is tomorrow is the last day to answer.
This week's assignment we can't discuss.
You need to make when using visualization technique. So there are 4 questions. So he may be addressing those.
Could be, yeah. So we'll discuss this next week. Yeah, thank you, Balaji. Yeah, Srinanda, you can go.
Hi. Okay, ma'am. So I think you mentioned something about how we can transform data retrieved from discussion forum. What did you say we do?
Yeah. So
because that's called data, no?
Yeah. That part is called discourse analysis.
Okay.
Yeah. So what we will do is we will try to extract what each person has typed. We will try to extract the text from the discussion forums.
Okay.
We will try to using different NLP technique. We will try to understand what was the tone of the discussion forum, what is the what you can say, the sentiment analysis we can do. Yeah, so we can have the set range of variables, like we can have some 2 tones, positive, negative,
Okay.
3 sentiments. So that means we have some categories or some labels to be used for that particular data, right?
Okay.
For that discourse and for that whatever you are typing in discussion forum. So that means to visually represent, because how can we represent the textual data visually? How can we measure the textual data visually? What will be the frequency and all these things? So in that type, these labeling or categorizing will come handy. We will label, we will assign certain labels, and then we'll try to plot those labels, or we'll try to plot those categories. So that's why histogram is not a good choice
And
for qualitative. Yeah?
Okay. Perfect. Okay. So in a classroom environment, we have biosensors like for facial recognition, and how are we converting that data when somebody is overjoyed, frustrated, confused? How do we track that data? And when we don't have human observers, when we are doing it through biosensors or cameras or whatever, how do we track that or convert that?
Right. So what happens is there are advanced deep learning algorithm, neural networks, ML algorithm, advanced machine learning algorithms. So there will be some set of so that machine learning algorithms which work like black box. You have seen these layers working, then layer 1, then layer 2, then layer 3, L1, L2, L3. So such deep learning algorithms are used to analyze each and every frame. So in that facial expressions of data, what happens is that facial expression data is recorded frame by frame, no? So every frame will have some visual image right? At this particular instance, what is my facial expression? So that
And so we break
image
it
will
down
be
into
captured.
different parts, small parts, or like
Small
that.
parts, and each facial expressions, whenever the change is happening, like I'm now giving different expressions, so that change is happening. So that is done using deep learning or complex machine learning algorithm, advanced machine learning algorithms. So ANN algorithms or some such advanced techniques are used to
This
do
ANN
this.
is also distance based.
We don't know what exactly ANN is based on, because this layers work in mysterious way. We don't know what goes back behind, so that's why the explainable EI is not. Have you heard about XAI? No. So now so now these advanced algorithms, they work like black box. You give them the input and they will somehow come up with the output when they have the label data. We don't know exactly what kind of algorithm they follow or what kind of set of rules they follow. Yeah, to understand that, there is this new branch called explainable AI or explainable machine learning algorithms that is now upcoming thing. We are trying to understand what algorithm these neural networks are applying to classify these things, to do that thing. So there are set of complex rules followed to I think we have taken this up in week 1 or week 2, I don't remember exactly, but this was precisely this example I had taken up, that where the machine learning or the predictive thing will come into picture. So at that time I had discussed this at length, that how the video recording and advanced machine learning is used to translate that video recording into the facial expressions into emotional state or affect state.
Affected states.
Affective state. Yeah.
Okay.
Yeah. So
ठीक है, thank you.
So again, that is also kind of, we are doing qualitative analysis, because we are wide range of emotion which is getting displayed. We are assigning labels to that emotions, and then there are learner centric emotions which are even less in number. There is just 6 learner centric emotions by Paul Ekman. So that Ekman's learner centric emotions are just 6. So that means we are labeling just 6 things to different facial expressions. So again, we are following the same.
You had mentioned once, for the inter-rater agreement part, when you were explaining, this also depends on geography.
On geography, on cultural settings also. The way we Indians will show happiness and frustrations while learning may not be applicable for some European student. They might show frustration differently while learning.
Right. Okay.
Yeah. So that's why these things come into picture.
Thank you, ma'am. Thank you.
So there is no universal algorithm applicable across our globe. कि ये एक ही algorithm है, ये expression मतलब frustration, ये expression मतलब happiness. That's not the rule. That's not the thumb rule. Yeah. So in such cases, that becomes a qualitative, which is not measured in anything. So that becomes a qualitative approach.
Okay.
Thank you. Yeah. Okay, if there are no more questions, then we can close today's meeting. Thank you all for joining. See you next week. Next week we can discuss this week's assignment, but not current week's assignment. Not ethical. Okay, so yeah, see you all next week. I'm ending this meeting. Thank you.